Okay, and our next speaker is Jeronimo Bernard is going to be from ACRI-ST, is going to be talking about development of scientific data applications for science cloud platforms.
All right. So thank you for that introduction, and hello everyone who is still joining us. So in this talk, we'll present our activities here at ACRI-ST to develop scientific data applications for cloud platforms. And I'll first present ACRI-ST, as most won't be familiar with it, and our motivation to do these applications. And then I'll show a little demo of one such of an application on Mars, and then also highlight another one on interstellar extinction maps, and present the idea or concept behind other apps that we're planning to develop. Okay, so first let's quickly explain our background and how we got to be here, basically. So ACRI-ST is an SME of the space sector, a supplier of space agencies, and they specialize on remote sensing observations of the Earth to better understand our environment. So we essentially provide engineering services on all aspects of data from satellites, including ground segment, instrument simulators, services for archival, distribution, storage, etc., as well as calibration and validation. An important part of our activities are with the Sentinel satellites of the Copernicus program, which is the European Union's program to observe the Earth. And now with this long history on Earth observations, we're now developing and expanding our activities in astrophysics and planetary science, since there are many synergies with our Earth observations activities. So what is our motivation? As we know, the era of big data is transforming the way many scientists approach their research, with new missions and facilities generating data that is becoming too large, too complex for local analysis. So these advances in observations require equal advances in data management and analysis, and has resulted in this paradigm shift to move the user and tools to the data. It's a paradigm shift that has already been evoked in several talks earlier today. Cloud computing, of course, an important advancement enabling this shift, such as the ESA Datalabs, of which we had a presentation earlier today, and the ESCAPE 2020 project, which has also been mentioned in several talks. In this spirit, ACRI-ST is interested in providing services in different areas related to these new developments. So, for example, data processing of mission facilities, run segment services for new space, development of scientific data applications, and thematic exploitation platforms, to say some. So for the rest of the talk now, I will highlight now our activities in development of scientific data applications that are planned to be deployed and accessible on different cloud platforms. So to start with, I highlight here our prototype application for the visualization of and exploration of Mars Express SPCAM Level 2 data products. For reference, the SPCAM instrument provides data on the Martian atmosphere, its trace gas constituents, and properties of aerosols. What we wanted from this application is that users should be able to make interactive data query and retrieval from the ESA Planetary Science Archive, interactively visualize this physical spatial information and display transmission, reflecting spectra, aerosol properties, and gas vertical density profiles. The application should also be able to manipulate the data to create local maps or data cubes, perform analysis of select data in combination with other VO tools. So now I'm going to show, it's not a demo, but I'm going to show a video to have a quick look at the interface, and which is narrated by my colleague, Nick Cox. So I'll just play the video. Oh, apparently there is no sound, I think.
No, we cannot hear it. We can't hear it.
Okay. Is there a way to...
Jeronimo, sorry to cut in. This is Nick speaking.
Yeah,
it's
so
not
you can
running.
do it.
It's not running either.
Well, so now I stop it, but
okay. So let me.
So maybe Nick can do it. Okay, since it was a tandem talk anyway.
Yep, and I'll do it on the fly.
The narrator. Okay, so I'll start, Nick. You can start.
Yes. Yes, okay. So this is a simple prototype application. We try to develop a new interface to access the SPICAM level 2 data in an intuitive way. So the first step is that we can select the data archives we want to check. So there's different instrument modes that can be searched. So you can select those, and then all the available data will be displayed in the planetary map, so the Mars map in this case. Is it still running?
No, I think it got, okay.
Ah, there it goes. So all the data get plotted on the 2D geo map, and all the data points are also listed in the table on the right. And so you can make sub-selections on the Martian year, on data columns, on the map to select certain regions. Also, so that's done here. Then we select the time window. We can restrict the local time or the latitude or the longitude, etc. Each of the columns that is in the database. Of course, we can export the results for analysis either in your own applications or send it to a VO application such as TopCut or SpecVis or anything like that. But of course, we can also look further inside this application to the data. So here, if I think it's paused again, Jeronimo.
Yeah.
It doesn't like to do it on its own. So we can also explore a bit already the data inside the browser, inside the application. So here I plot all the level 2B data, which are the atmospheric density profiles of carbon dioxide or water. So we can select those. We can select the aerosol vertical profiles, etc. Well, we have this typical interactive plot so that you can explore the different profiles in detail, and you can then select also specific profiles to retrieve the underlying level 2A data set, which
5
I
minutes.
do here. Yep. And so here you can see that the data transmission spectra that were used to make the retrieval of the atmospheric properties is shown. So you can look back at the level 2A data that was used in that. So this is the first step of this application, and we want to develop more functionality and include more data sets, etc. Okay, so here I zoom in a bit on the water features. And I think I'm pretty close to the end of the video.
I think this is the end, Nick. So.
Yeah.
Okay, thanks, Nick, for that. I'll take over now, and sorry about that glitch. So basically, we plan to make this application available in the ESA Datalabs, and also because of the similarities with Mars Express SPICAM data and its sister mission, Venus Express, we will allow to easily export this application from Mars to Venus, which we, of course, plans to do. Now, another application we'd like to highlight is the 3D extinction map services. Currently, we are hosting a straightforward web service shown here that users can use to query 3D DOS tomography cube produced as part of the STILISM project. This is a project led by Rosine Lagimont from GEPI, and to which ACRI-ST contributed, and which produced volumetric maps of the local interstellar matter. Users can get cumulative extinction for a given line of sight or extract planar, for instance, extinction maps as shown here. Also here, there is the link in case you wanna try it. Now we're improving this. We are now developing a more advanced tool to exploit these 3D tomographic data sets. In particular, we are connecting it, the DOX extinction data to the ESA Gaia archive, another database. For instance, this show here in the figure, the cumulative extinction to a given target that is shown in the bottom, which user can use to correct their observations from extinction, and the red dots are, for instance, the Gaia targets in that line of sight. Or, of course, you can also display the extinction as a function of distance, like here, where each peak, in fact, signals sort of like the presence of a dust cloud. Also, we are adding a new 3D data visualization options that will help astronomers explore the data more effectively, hopefully, and as well as other features. Now, for the rest of the talk, I will simply present the concept and goals of a set of projects which have just started. So the first project is called Explore. This is an H2020 project which ACRI-ST is coordinating and partnering with academic institutions and research centers. So the kickoff is actually tomorrow for this project. So what is Explore? Explore, its main objective is to deploy machine learning and advanced visualization tools for lunar exploration and Gaia, galactic and stellar science. Explorer basically sits between data collection from space and ground-based facilities and the provision of these science data produced to science archives and cloud science platforms such as EDL and ESCAPE. So within Explore, we will develop 6 applications. 4 of these will be focused on Gaia data, 2 on galactic processes, 2 on stars, but we'll also use other space and ground-based data from ESA and CDS. The other 2 applications provide different tools to explore the lunar surface. So for example, here's DISCO will use AI for anomaly similarity detection of spectra from large data sets. And also here below is a mock-up of a geophysical browser for the lunar exploration and lunar X applications, which will be the entry point for data analysis, a sort of a lunar exploration platform. Now, as part of the Europlanet research infrastructure, ACRI-ST is also involved in machine learning work package to develop machine learning tools for the planetary science community and possible onboarding of the tools to the European Open Science Cloud. So the idea is to basically do some basic machine learning tools based on selected science cases listed here that can be then used and adapted by the community.
1 minute.
Okay, so I don't have much time, but I will say that some of these tools include landform classification from images and automatic detection of features in time series of data. So this could be a detection of surface in Mars or time series like these interplanetary coronal mass ejections. Then here we have another one, which is a similar case, but for instance, using time series to detect different magnetoboundaries in Mercury using messenger data, some of which are highlighted in these figures and where we already have a very preliminary results. But the idea is that once these tools are more mature, they will be more available to the community through different platforms. And then just to finish, then I would like to finish with another project that we're about to start at the end of this month to provide data fusion tools for the James Webb MIRI instrument. This is a joint project with the EAS that is partly funded by the French research agency to combine spectroscopic and imaging expertise to develop new methodologies for data fusion. Essentially, the MIRI imager provides high spatial resolution in a large field of view, but in a limited set of bands where there is a lot of things mixed, as you see in the spectra, and the spectrometer provides high spectral resolution in a small region. And the idea is to combine the best of those worlds. Essentially, if you look at the given MIRI band on the bottom, there is a lot that contributes to it. So we hope that we should be able to correct for that and get the spatial distribution of different species of features in the map. This tool will be made available to the community via the like of French MIRI Center Sepertix MICE. And then, okay, these are some of the partners. Of course, all these projects are not done in isolation, but bringing together a broad range of expertise and interest. And that's it. Just to conclude, to say that we are putting together a website at ACRI-ST to provide information about all of these our activities in astrophysics and planetary science. It is not yet active, but will be very soon. So stay tuned. And I thank you for your attention.
Okay, we have one of the questions has disappeared. I think, Christoph, I don't know if you had a question. If you did, it's gone. Maybe you meant to do that. But we have another question. Which web technology do you use for back-end and front-end development?
So all these tools are now done with Python, basically. But then basically for the applications, the idea is to put them in containers, Dockerized containers. So these are many of them, as you can see, they just started. So it's a lot of development to do.
Do you have a time frame for when some of these are going to be available?
We hope that the Mars app could be available in a few months. Certainly within a year. Then the other projects I mentioned, they're a bit long-term projects. So one is 3 years, the other is 3 years. But of course, we'll hope to have a few of the basically prototypes earlier, right? In 1-2 years. But basically, we're working in several of them. So we hope to basically make some available, start making some available next year.
Okay, we have a question. Do you plan for API access for any of these services? Or I think that was, I'm not sure if that was for you or not. Sorry.
Yeah, I'm not sure.
Never mind. Well, I mean, if you have an answer for that, please go ahead. If not, I will assume that was for a different person. Sorry, it's sometimes hard to follow that in Discord.
Yeah, but yeah, in principle, yes. Yeah, we will.
Do we have any other questions? Okay, let's thank Jeronimo and Nick once more.